Have you ever wondered, did Mars once breathe like Earth? Why is Mars dry and lifeless now, while Earth is full of oceans and forests? And could Mars long ago have been our second home? About 4.6 billion years ago, when the Sun and planets were forming from a swirling cloud of gas and dust, two rocky worlds were born from the same cosmic ingredients, Earth and Mars. They both had metal cores, molten mantles, and solid crusts. At first, they looked remarkably similar. Both were warm, geologically active, and wrapped in thick atmospheres. Mars, in its early days, had rivers, lakes, and possibly even an ocean stretching across its northern hemisphere. There were clouds, rain, and a blue sky. It wasn't always the red, frozen desert we see today. Then something changed. Around 4 billion years ago, Mars lost its magnetic field, the invisible shield that protects a planet from solar wind. Without that shield, charged particles from the Sun stripped away its atmosphere bit by bit. The air thinned until it was less than 1% the pressure of Earth's. Water boiled off or froze beneath the surface, and temperatures dropped drastically. Today, scientists estimate that more than 5 million cubic kilometers of water still exist on Mars, locked away as underground ice. In 1971, NASA's Mariner 9 orbiter sent back the first clear images of Martian landscapes shaped by ancient rivers and floods. Later, missions like Viking, Mars Express, Curiosity, and Perseverance revealed even more clues. They found clay minerals, layered rocks, and rounded pebbles that could only form in liquid water. Inside Gale Crater, Curiosity discovered stones smoothed by ancient streams, clear proof that Mars once had flowing water. More recently, scientists noticed strange wave-like patterns on the Martian surface, signs of melting and refreezing cycles, suggesting that Mars once had fluctuating climates. NASA's InSight lander also revealed that Mars has a solid metallic core about 613 kilometers in radius, remarkably similar in structure to Earth's. But the two worlds diverge sharply. Mars is smaller and lighter. Its gravity is just 38% of Earth's. Its atmosphere is 95% carbon dioxide and too thin to trap warmth. The average temperature is around -60 degrees Celsius. Without a magnetic field, cosmic radiation constantly bombards the planet's surface. If we think of the story of Mars in 4 chapters, it goes like this. First, formation from the same solar material as Earth. Second, a warm and watery period with a thick, protective atmosphere. Third, the loss of that shield and the slow collapse into a frozen world. And finally, the modern era of human exploration and rediscovery. The numbers reveal even more. Over 40,000 branching valleys have been mapped on Mars, evidence of a vast, ancient network of rivers. If all the remaining ice melted, it could cover the entire planet with a 35-meter deep ocean. Mars tilts on its axis by about 25 degrees, almost the same as Earth's 23.5 degrees, which means it also has seasons. But since a Martian year lasts 687 days, each season lasts nearly twice as long as ours. Comparing then and now is like seeing 2 photographs of the same planet, one alive, one silent. Mars once had a blue sky, liquid water, and possibly the ingredients for life. Now it's a quiet world of dust and ice. Yet that silence teaches us something profound. Studying Mars helps us understand what makes a planet habitable and what destroys its balance. It's driven technology forward, better sensors, stronger drills, and advanced AI for analyzing terrain. The same satellite algorithms developed for Mars now monitor Earth's changing climate and detect underground water. But these discoveries come with challenges: enormous mission costs, radiation hazards, and the complexity of landing and bringing samples back. Still, Mars continues to shape our future. Technology created for rovers now helps in mining, agriculture, and even medicine on Earth. And the dream of living on Mars pushes science into new frontiers like genetics, synthetic ecosystems, and the ethics of creating life beyond Earth. So the question remains, could we ever make Mars like Earth again? Could terraforming, rebuilding its atmosphere and raising its temperature, bring back oceans and blue skies? Should humanity even try to remake another world? Or are we chasing a reflection of what we already have and might lose here on Earth? the story isn't over. Every day, new data arrives from orbiters and rovers, rewriting what we thought we knew. And maybe one day we'll see the first green sprout rise from Martian soil. Until then, we keep searching, learning, and dreaming. Because Mars isn't just a distant planet, it's a mirror showing us what Earth could become and what we might yet save. What do you think? Could Mars ever truly be like Earth again? Share your thoughts below. I'd love to know how you see the future of our red twin.